So let's look at the output it produced. And so now do path, up to date, all of these functions are documented. Welcome back to episode 13 of Haskell from Scratch, where we'll be finally adding some documentation to our program. So far, there's been an embarrassing lack of comments in the code, and the README file that we have is really just a placeholder. I tend to think about documentation for code on 3 levels, and I've written about this on my site before. And those levels are: first, we need to have some documentation that gives us a broad overview of what the purpose of the program is, what it accomplishes, how it does it, why it was created, and so on. And this kind of documentation tends to be external to the code. Next is what I think of as the top-level documentation, and this is the documentation of all of the top-level function or type definitions inside of the source code. So we want to document, for example, what is metadir, what does this function redo, and this function doPath, and this up-to-date, and so on. What do these do? And in most languages, these are served by something like Javadoc, where you have comments that have some sort of specification for minimal formatting that you can generate some HTML documentation from. Haskell's no exception here. It has Haddock, and I'll be using that in this video. And then finally, there's what I think of as line-level documentation, where you explain at a low level what's going on. So for example, here we could say, explaining this part of a case branch, that a target is up to date if, or rather a dependency is up to date if the MD5s match and it itself is up to date, i.e. all of its dependencies are up to date. And I tend to go a little bit overboard with these type of comments, having a running narrative in the code, which brings me to the topic of literate programming. Now, Haskell's a bit rare in that it supports a type of literate programming right out of the box, and it even has a form that shifts the emphasis to the documentation so that anything that is just typed in by default, this is literate text, is considered text or documentation, and you have to explicitly mark blocks of code. And I used this for a while. I was a big fan of literate programming as explained and demonstrated by Donald Knuth, but I found in my own personal experience that modern languages, especially Haskell, have a lot less need for the type of literate documentation that programs like Tech and some of other Knuth's programs needed. And a lot of that was due to limitations in the compiler and requirements on ordering and so on. I also find that with Haskell, so many functions are pulled out and turned into generic functions that it doesn't really make sense to document the entire program as a running commentary. But I have nothing against literate programming, and if you want to use it, I think it's better than no documentation at all. So I'm going to start from the top and add more to this README file before doing anything else, and I'll see you in a bit. All right, that took a little bit longer than I expected, but I like the idea of having as much or more documentation than code for a program. So that's enough top-level documentation for now. I went ahead and made a readme.html.do file to convert this for testing so that we can type redo readme.html and then take a look at it in a browser just to proof it before committing it to GitHub. And I've already done that. You can see the details here. So let's go now and start adding some documentation to the code itself, and what I refer to as top-level documentation. And to do this, I'm going to be using Haddock. So we'll start by documenting what this metadir is here. So Haddock, like most other documentation systems, uses a special syntax inside of comments to indicate that something is a special type of documentation. So for the top level here, we just use a pipe and say, this is the directory that redo will store and read metadata on targets from. And I'll clean these up later when I'm not on camera, but you can get the idea here. And one of the things I really like about Haskell is that so many things are just simply top-level definitions. I mean, even looking at our code right now, pretty much everything aside from these imports fits as a top-level definition. So let's take a look at the type of output this produces by running Haddock on it. And running Haddock manually from the command line itself has some problems because it can't find where certain things are. So if we say, if we try to run Haddock on redo.hs, it tells us it can't find linked destinations for IO, for example. So let's instead use Cabal dev to run Haddock now that we have a Cabal file. And by default, Haddock was really intended for library documentation. So Cabal is telling us that it's not going to build any documentation for our project because it's an executable. So let's just add the executables flag. And now it has generated some documentation. So let's take a look at that. This doc HTML redo index. Okay. So this part at the top here is probably coming from our Cabal file. The description line here. And then the modules we have is main. And we didn't actually specify any modules in our project. There's no module keyword here, but by default, this module is presumed to be main. And you can see that from the Cabal file. Main is redo.hs. So when we look inside of that, unfortunately, there's no documentation here. But I know that the syntax here for this Haddock for metadir is correct. And what's happening is that Haddock only creates documentation for top levels that have been exported. And since we haven't created a module definition like this and exported anything from it, such as, say, metadir, then we won't see any documentation. So let's try that again. And now we get some warnings about things being defined but not used, but we do have the documentation now for metadir. However, this introduces another problem building this project. So if we say Cabal dev install, notice that it complains that there's no main function exported by the main module, and this is important for any program that's written in Haskell, so you need to add main there. Okay, so documenting metadir was pretty straightforward. It's just simply binding a name to a string. What about documenting a more complicated function that takes arguments like this? So we can say rebuild a given target if it's out of date or doesn't exist. But we also want to document the arguments to the function, and so we can do that by just changing the formatting here a little bit, moving each of these arguments and the result onto a different line, and then using a comment with a caret to say that this is the target file name, and this is the current directory, and this is that kind of wonky argument that was for output purposes only. And the result here, there's nothing to say about this. We just generate some I/O actions. So let's take a look at that. And instead of adding this to the output list as well, or the export list rather, we can just remove the export list altogether and everything will be exported. So let's generate the documentation and see that Haddock will tell us the coverage of how much we've documented in the module. So we've documented 2 out of 9 of these top-level functions that get exported. And so now, looking at the documentation again, notice that everything has been added here, whether it has documentation or not. And we have documentation for the redo function that includes comments on what these arguments are. Now, let's say I don't want to include functions that don't have any documentation for them. I can do that by specifying an option to Haddock called prune, I believe it is. And that tells Haddock to only include the functions that have been exported from the module and that have documentation for them. So let's see the result there. And that looks great. So I'm going to again pause while I add top-level documentation for all of these, and I'll see you in a moment. Okay, that didn't take nearly as long as writing the README file, and it was pretty straightforward, so it should just work the first time here. So ran Haddock. There are 2 things that aren't covered. One of them is main, because that should be well understood. And the other it's probably complaining about is the module. You can document what a module is, but I don't think it makes sense for a program like this. I think it makes more sense for a library where you have a number of modules. So let's look at the output it produced. And so now do path, up to date, all of these functions are documented. One thing I find when writing the documentation is that when the documentation is difficult to write or doesn't make sense when I reread it, that's usually an indication to me that the underlying code has a problem and has confused things. For example, this write MD5 is especially confusing. You pass it a target, you pass it a dependency. What is it doing? Is it writing an MD5 for the target or for the dependency? But rather than try and fix that right now, I'm just going to leave a note. This function is confusing. Oops. Which are we writing which for? And go back and clean this up later when I'm not in documentation writing mode. Because right now I want to get on to the 3rd level of documentation, and that's these sort of line level comments that give a commentary on the decisions that were made and why certain code is doing what it does, that I think is really valuable when you're refactoring or doing maintenance on the code. But really briefly before that, I want to point out that Haddock has some markup inside of it that you can use for making the documentation a little bit more useful. Let's use it for documenting this file MD5 by providing an example of what it does. That should make it a little bit easier to understand. So for example, we can say that, for example, and you can document examples in Haddock by sort of like a read eval print loop in GHCI, where you put 3 arrows and what you would type into GHCI. So let's say you did file MD5 of redo.hs and then print the result on the next line here. So in our case, MD5 of redo.hs gives us this. And so let's pretend we're returning a result from in GHCI, and add a little bit more white space here with some blank lines in case someone is reading this inside of the source, not inside of the HTML documentation. So one more time, we'll rebuild this and then go take a look. And now there's our example. Okay, so once again, I am now going to go through this code and just add some line level documentation to it, and then I'll show you what I've done in a moment. And here it is. I tend to go a little bit overboard with this type of documentation, and maybe it's because I've been scarred by coming back to some code I've written after a long period of time and being absolutely confused at what's going on inside of it. So I tend to write these long narratives, and you can see the size of the file has gone up quite a bit. We can look at, let's get a line of code count here on the file, and now there's more comment lines than code lines, but this is my style. I like to have a lot of comments and documentation, but I don't necessarily think this is for everyone. And as I was writing these, I added some to-dos for things I noticed that were wrong or needed to be changed, like this one about adjusting the path, some future changes, and even some documentation or possible logical errors that I made note of that I wouldn't have normally noticed unless I was reading through the code trying to document it pretty thoroughly. Not only is this documentation useful for other people, but I think it acts as a sort of code review from yourself. If you can't find somebody else to review your code, maybe the next best thing is going through and documenting your code, because it forces you to shift your perspective a little bit to somebody else looking at the code or somebody else using the code. So that's all for this episode on documentation. In the next episode, we'll either be looking at measuring the performance of our implementation, or we'll be going through some more refactoring in light of all these to-dos I've added. Thanks for watching, and I'll see you then.